On this 6.2L Superduty, P0335 is a crankshaft position signal fault. In plain terms, the PCM may not be seeing the CKP pulse it expects while the engine is being cranked, or when engine speed is high enough for the signal to matter. The truck may crank and not start, and a missing CKP signal can show up as 0 RPM while cranking. Broadly, think in 4 areas: the CKP sensor circuit, the crankshaft pulse wheel, the CKP sensor itself, and the PCM. If other codes are present, check what they mean first, because this diagnostic routine is shared with other crank and sync concerns, but we are staying focused on P0335 here. Begin by making sure the battery is fully charged and the starting system is working correctly. Disable the fuel pump by removing the fuel pump fuse. Turn the ignition on, access the PCM data, and monitor the RPM PID while cranking the engine. Normal cranking speed is between 150 RPM and 350 RPM, and the engine should crank for greater than 3 seconds while attempting to start. For this first decision, look for RPM greater than 150. With P0335, if RPM is greater than 150, keep moving down the CKP diagnostic and inspect the sensor and trigger wheel. If there is no RPM signal and the engine cranks less than 3 seconds, do not jump into circuit testing yet. Verify base engine timing, make sure the camshaft sensor trigger wheels are not damaged, and confirm the camshafts are rotating while the engine is cranking. Repair as necessary. Clear the PCM DTCs and repeat the self-test. For the other no RPM situations on this P0335 diagnostic, continue to the sensor and trigger wheel inspection. Turn the ignition off and look closely at the CKP sensor area and the trigger wheel. Check the trigger wheel for contamination, debris, and physical damage. A trigger wheel that is damaged, bent more than 1.0 millimeters, or contaminated on the magnetic surfaces may cause an intermittent CKP signal. If you find a real concern here, repair as necessary, reset keep alive memory, and carry out the misfire monitor neutral profile correction with the scan tool. If there is no obvious physical concern, continue with the electrical checks in the order your test result sends you. Next, on the CKP plus and CKP minus side of the circuit, disconnect the CKP sensor connector. Turn the ignition on and measure voltage between CKP plus and CKP minus at the CKP sensor connector. The voltage should be between 1 volt and 3 volts. If that bias voltage is in range, turn the ignition off and check the CKP sensor resistance on the component side between CKP plus and CKP minus. The sensor resistance should be between 250 ohms and 1100 ohms. If the sensor resistance is not in that range, the supported call is to install a new crankshaft position sensor, reset keep alive memory, and carry out the misfire monitor neutral profile correction with the scan tool. If the bias voltage is not in range or the sensor resistance passes, continue into the circuit integrity checks instead of guessing. For the harness shield ground check, turn the ignition off, disconnect the PCM connector, and measure resistance between CKP_shield at the CKP_shield assembly connector and CKP_shield at the PCM connector. The shield is built into the harness around the CKP circuits to protect the CKP signal from outside electrical noise, and it is grounded internally through the PCM. That shield ground resistance should be less than 5 ohms. If it is not, repair the open circuit and check for an intermittent ground connection, then clear the PCM DTCs and repeat the self-test. Next, check for a short between CKP plus and CKP plus at the CKP sensor connector. That resistance should be greater than 10,000 ohms. If it is not, repair the short circuit, clear the PCM DTCs, and repeat the self-test. Then check both CKP circuits for opens, CKP minus at the sensor connector to CKP minus at the PCM connector, and CKP plus at the sensor connector to CKP plus at the PCM connector. Each open circuit check should be less than 5 ohms. If either one is not, repair the open circuit, clear the PCM DTCs, and repeat the self-test. After that, check the CKP circuits for a short to ground by measuring between CKP plus and CKP minus at the CKP sensor connector. That resistance should be greater than 10,000 ohms. If it is not, repair the short circuit, clear the PCM DTCs, and repeat the self-test. Finally, in this group, turn the ignition on and measure voltage between CKP plus and CKP minus at the CKP sensor connector. If any voltage is present, repair the short circuit, clear the PCM DTCs, and repeat the self-test. If no voltage is present, move on to the intermittent harness check. The other CKP sensor check starts with the ignition off and the CKP sensor connector disconnected. Turn the ignition on and measure voltage between VREF pin 1 and SIG-RTN pin 2 at the CKP sensor connector. The expected voltage is between 4.5 volts to 5.5 volts. If that voltage is not in range, do not keep interpreting the CKP signal until that failed voltage result is handled. If the voltage is between 4.5 volts to 5.5 volts, continue with the CKP signal circuit checks. Turn the ignition off and disconnect the PCM connector. Check for an open by measuring resistance between CKP pin 3 at the CKP sensor connector and CKP pin E78 at the PCM connector. The resistance should be less than 5 ohms. If it is not, repair the open circuit, clear the PCM DTCs, and repeat the self-test. If that circuit checks good, check for shorts between circuits. Measure from CKP pin 3 at the CKP sensor connector to VREF pin 1, and then from CKP pin 3 to SIG-RTN pin 2. Those readings should be greater than 10,000 ohms. If either check fails, repair the short circuit, clear the PCM DTCs, and repeat the self-test. Next, turn the ignition on and check CKP pin 3 at the CKP sensor connector for unwanted voltage. Any voltage present means repair the short circuit, clear the PCM DTCs, and repeat the self-test. If no voltage is present, continue to the intermittent harness inspection. If the circuit tests pass and there is no unwanted voltage, turn the ignition off and reconnect the PCM connector. Now do an intermittent check. Visually inspect for chafed CKP and CMP wiring, or any other physical damage in the harness. Chafing or harness damage can create an intermittent short in the CKP or CMP circuits. If you find a concern, repair as necessary, clear the PCM DTCs, and repeat the self-test. If nothing is found, move to the connector seating and terminal inspection. For the final check, turn the ignition off, disconnect the PCM connector and the CKP sensor connector, and inspect for pushed-out pins and corrosion. Then reconnect all PCM connectors and the CKP sensor connector, and make sure they are fully seated. Verify whether the concern is still present. If the concern is still present and the symptom is cranks no start, stop here, and handle it as a no start before condemning the sensor. If the concern is still present without that no start branch, install a new crankshaft position sensor, reset keep alive memory, and carry out the misfire monitor neutral profile correction with the scan tool. If the concern is no longer present, the system is operating correctly at this time, and the issue may have been caused by a loose or corroded connector. The takeaway is simple. Prove the RPM signal first, inspect the wheel and sensor area, verify the voltage and signal circuits, look hard for intermittent harness damage, and only make the sensor call after the wiring and connector checks support it. For more diagnostic training, visit stepdiagnostics.com.